Hello all, welcome to yet another session on cryptography, network security and cyber laws. Now in this module 3 of session 10 we will be discussing about security at transport layer. Now the agenda of today's discussion of the session includes we will be introducing you to the concepts of SSL protocol, what exactly we mean by SSL protocol, how it changes our routine application protocols, and also we will see at the various protocols involved in this particular SSL protocol stack. Now at the end of this session you will be able to explain what we mean by an SSL protocol and the various protocols that are involved in this particular SSL protocol stack and their functionalities. Followed by that you will also be able to describe the various steps involved in performing an SSL handshake. Now moving on, let us try to understand what we mean by SSL protocol, and also we will see the various protocols that are present in this particular SSL protocol stack and each of their functionalities. Now the secure socket layer is a protocol. Now this protocol is required to establish a secure communication between two communicating parties, that is the client and the server. This particular protocol was developed in 1994 by Netscape, and also it was standardized by IETF in 1999. This secure socket layer protocol is also referred to as transport layer security or TLS. Now in our further discussion we can use SSL and TLS intermittently. Moving further, SSL is a protocol that is sandwiched between two layers. One is the TCP layer and the other one is the application layer. Now this protocol is independent of any of the other protocols of other layers, be it application layer or the TCP layer or the network layer. Now this application layer protocols can be run or they run on the SSL in order to secure themselves. Now the application layer protocols include FTP, HTTP, SMTP, IMAP and POP. FTP, let's look at each one of these now. FTP stands for File Transfer Protocol. Now this file transfer protocol is responsible for transmitting files from one client to another client. Now this FTP is used when we are transmitting huge files. Now what do we mean by HTTP? HTTP stands for Hypertext Transfer Protocol. Now this application layer protocol is used for providing data communication in World Wide Web. The next one is SMTP. SMTP is an application layer protocol which first stands for Simple Mail Transfer Protocol. It is a standard protocol on TCP/IP network for sending emails through server. Now the other protocols of the application layer are IMAP. Now what does IMAP stand for? IMAP stands for Internet Message Access Protocol. Now this application layer protocol is a mail protocol used for accessing email on a remote web server from a local client. Now the last protocol of the application layer that we are going to discuss is the POP protocol. POP stands for Post Office Protocol. Now this Post Office Protocol is used as a protocol to retrieve email from an email server. Now most of the email applications currently make use of the POP protocol. Also, some of them are based on IMAP protocol. Now, all of these application layer protocols can be subjected to run over the secure socket layer protocol and make these protocols secure. Now, when these application layer protocols, when they run over the secure socket layer protocol, we refer to these application layer protocols with a suffix s. FTP becomes FTPS. HTTP becomes HTTPS. Similarly, SMTP becomes SMTPS. IMAP becomes IMAPs and POP become POPs. Now, what do we mean by this? Now, all of these protocols become secure once they run on the secure socket layer protocol. Now, all of these application layer protocols run on a particular port, or they are allotted a particular port. FTP is allotted a port number 21 and HTTP is allotted a port number 80. Now, the counterparts, that is the secure counterparts of these particular protocols, cannot run on the same port number. They are allotted different port numbers to run securely. Now, the regular HTTP runs on a port number 80, whereas the secure counterpart of HTTP, that is HTTPS, runs on the port number 443. Similarly, regular FTP applications run on port number 21. But the FTP, which runs over the secure socket layer protocol, runs on the port number 990. Moving further, let us have a look on the protocol stack of SSL. SSL has two protocols. Now over here we can see that this SSL is sandwiched between the application layer and the TCP layer. Now there are two, SSL in turn has two protocols. Now one protocol is the SSL handshake protocol and the other one is the record layer protocol. Now let us see what we mean by a handshake protocol and a record layer protocol. Now a recap of this is we have application layer and a TCP layer, and between these two layers we have the secure socket layer protocol. The secure socket layer protocols are two. One is the handshake protocol and the other one is the record layer protocol. Now what happens in the secure socket layer protocol with handshake? Now over here for the handshake protocol there is a lot of negotiation of algorithms that occurs in order to secure the communication link. The question that arises over here is, what are the algorithms that will be used in order to secure the communication links? Now these algorithms include the encryption algorithms. We are aware that encryption is used to achieve confidentiality. Next is, which key exchange algorithm will be used in order to exchange the keys securely between the communicating parties. The third negotiation of algorithms is which hash algorithm will be used in the computation of hash, whether it is MD5 or SHA-1 or whatever. Now, after the negotiation of algorithm, this protocol, that is the handshake protocol, is also responsible for authentication of the server. The server gets authenticated to the client, and also this protocol is responsible for derivation of keys that are used for encryption in order to achieve confidentiality. Further, this protocol, handshake protocol, also decides and derives the keys that are used for computation of MAC. Now over here we'll see the other protocol involved in SSL, which is the SSL record protocol. Now this SSL record protocol is responsible for providing message authentication along with integrity check. Now what do we mean by message authentication? Once the receiver receives the message, the receiver is able to verify that the message has come from an genuine source, and also the receiver is able to verify that the message it has received is not altered during the transmission. So these two checks can be performed or are performed by the record protocol. The other service that is provided by the secure socket layer record protocol is encryption. Now we are aware that encryption is used for achieving confidentiality. The other functionalities, the other points to be discussed are: this protocol is placed below the handshake protocol. Now we have seen in this diagram that this particular record layer protocol is placed below the handshake protocol in the protocol stack. Now this protocol is responsible for protecting each message that is exchanged between the communicating parties, and also this protocol is responsible for detecting if the packets are replayed, reordered, or if there are any duplication of packets. Now, having understood the functionality of the handshake protocol and the record protocol, we will move further with discussing the various steps involved in SSL handshake. Now in this session we will just be discussing the steps involved in SSL handshake. Now the key design ideas, which is a subtopic of SSL handshake, will be discussed in the next session. Now over here, the initiation of a handshake is done by the client to the server. The client requests the server to start a new session, or it could ask for the server to resume an existing session which has been halted for some purpose, or the client could ask the server to establish a new connection in the existing session. Now if in case the client is asking the server to start a new session, then it is a huge overweight because there is a lot of communication that is involved. If in case this client asks the server to establish a new connection within an existing session, in that case it is advantageous since less communication is involved, and hence we call such a method of establishing new connection in an existing session as lightweight. Now over here, the only thing to note is we obtain a fresh keys which are used for integrity protection and encryption. Now these methods will be discussed in detail in subsequent slides. Now let us look at the various steps involved in establishing a new session in SSL handshake. Now there are 4 steps that are involved. Now the first step is agreement of a common cipher suite that will be used in a new session. Here, the client and the server decide upon the various security parameters that they will be using during the current session. The second step is receipt and validation of a server certificate by client. Over here the server sends the server certificate to the client, and the client receives this particular server certificate and validates the server certificate. The step 3 is responsible for communication of a pre-master secret key and computation of various derived secrets. The step 4 is responsible for integrity verification and handshake messages and server authentication. Now the messages that are exchanged during in order to establish this particular communication during the handshake are verified over here in this step 4, and also the server is authenticated to the client in the step 4. Now let us look at this particular diagram and understand the various steps involved in this particular establishment of handshake. Now over here we can see that the client is trying to establish a communication with the server. The client initiates the communication with the server by sending a client hello message. On receiving the client hello message, the server responds back to the client using a server hello message. And also the server sends the server certificate. Now the server certificate, as we have seen, is sent in step 2. The client sends the client key exchange. Now this happens in step 3. Now in step 4, we have 4 messages that are exchanged between the client and the server. 2 messages from the client and 2 messages from the server to the client. The client sends the server and asks it to change the cipher specifications that will be used further. And also it sends a finished message to the server. Now the server sends back the changed cipher specs and also the finished message to the client. At the end of the step 4, the client and the server are able to verify the integrity of the messages that are exchanged prior in the handshake, and also the client is able to verify the authenticity of the server. Now let us see what happens further. Now in the step 1, there is an agreement that occurs between the client and the server on a cipher suit that will be used for this particular session that is going to be established. Now in this step, there are 2 messages that are communicated. One, the client that initiates the communication with that of the server, that is using client hello, and the server which responds back with a server hello. Now when a client sends a hello message, the following decisions will be taken. Whether the client is asking the server to establish a new connection, to establish a new session, or to use a existing session. If the client is asking the server to establish a new session, in that case, the session ID field in the client hello message is set to 0. Now, if it is using an existing session, in that case, the session ID set in the session ID field is reused. Similarly, the server, when it sends a server hello message, the following decisions are taken. Now if the client is asking for establishing a new session or starting a new session, in that case the session ID field in the server hello message is set to a new ID. Or if the client is asking to use an existing session, in that case the session ID is reused. Now what are the other things that happen during this particular handshake? Over here we need to this particular step decides on the algorithm that will be used in computing the MAC for message integrity. Now we need to decide upon what algorithm is actually used in order to calculate the MAC for message integrity, whether it is a SHA-1 algorithm or an MD5 algorithm. The second thing that we discuss that needs to be decided over here in this particular step 1 is that is message confidentiality required for this particular message exchange. Now if there is an S, if the message confidentiality is required, then we need to then there is a need to decide upon the encryption algorithms that will be used. We are aware of the various encryption algorithms available. It could be DES, triple DES, AES, RC4 and so on. Now after deciding that confidentiality is required and also on deciding the encryption algorithm, we need to decide upon the key length. What is the actual key length that will be used in order to achieve this confidentiality has to be decided in this particular step 1 of the handshake. The next thing that has to be decided in this step 1 is the key exchange method that is used in order to communicate the pre-master secret. Also, we need to decide upon the factors such as, let's look at this, such as various nonces that will be used in order to achieve the secure communication. Now over here in step 1, both the communicating parties have to select two 32-byte nonces which are referred to as RA and RB. Now over here for MAC, we are the step now this particular step will decide whether to use MD5 or SHA. If message confidentiality is required, in that case it decides whether to use DES, AES, triple DES or whatever, and upon deciding the algorithm they have to decide on what key length has to be used, and also what is the method that is used to exchange the secret keys, pre-master secret, that is RSA or a Diffie-Hellman key exchange algorithm, and also on the various nonces a decision has to be taken in this particular step 1. Now all these parameters account to what we call as cipher suite, which are used to establish a new session. Moving further, in the step 2, as already told, the server sends back its server certificate. The client receives the server certificate and then validates this particular server certificate. Now this step involves only one message which is communicated from the server to the client. The server sends the certificate to the client. Now on the receipt of the certificate by the client, what happens is this client first checks the owner's name, the URL, and whether this particular certificate received from this particular server, which is the owner, is still valid or not, whether it is still having the validity period. And also it verifies the signature of the certificate authority on the certificate. Now even after verification of the signature of certificate authority and also checking all of these other parameters, still this does not guarantee that the server is authentic. The server certificate is transmitted in clear. It is not encrypted or it is not hidden or masked in any way and sent to the client. Now since this certificate is sent or transmitted to the client in clear form or clear message form, anybody is able to impersonate this particular server. Now, hence, we need to authenticate this server. Authentication of this server is performed in step 4. Now, moving further, having understood that in the step 1, we perform two communication starting from the client to the server, which sends the client hello, and the server responds back with the server hello. Over here in this step 1, both client and server decide upon the cipher suite that will be used for this particular new session. And also moving further, we have discussed what we mean by step 2. In the step 2, the server is sending to the client a certificate, a server certificate, and this certificate is checked and verified by the client. But this verification is not enough to guarantee the authenticity of the server. Now authentication of the server is further done in step 4. Now let's see what happens in step 3. Step 3 is responsible for communication of a pre-master secret key and communication of derived secrets. Now communication of pre-master secret is exchange of secret key between the client and the server. And computation of derived secrets, we will see what are the other derived secrets that are required here. Now in this step 3, only one message is communicated from the client to the server. Now over here in this particular step, the client chooses a pre-master secret, and this pre-master secret is 48-byte random number. Now this secret is then encrypted using server's public key. this pre-master secret, over here we can see it is encrypted using the public key of the server. And then after encryption, using the public key of the server, it is sent to the server. Now who is able to decrypt this key? Only the server, because server can use his private key in order to decrypt and get the pre-master secret. Now both the client and the server compute the master secret. Now how is this master secret computed? The master secret is computed using F. F is a HMAC function. Now this HMAC function is applied on the pre-master secret. RA and RB, as we already discussed, they are nonces, and also we have various constants. Over all of these parameters, this cryptographic function F is applied. Now this cryptographic function could be either MD5 or SHA. Now the outcome of applying this function, we get a master key. Also, 6 secrets are derived using HMAC style functions over the master secret nonces and predefined constants. Now over here we can see that we are using again HMAC style function F over the master secret, and also RA, RB, which are the nonces, and constants which are predefined. And all of these together we call it as derived secret. Now since there are 6 secrets that are derived, we refer to I, and I is ranging between 1 to 6. Now let us see the previous slide. The master secret is a function of the pre-master secret, the nonces and the constants, whereas the derived secret is a function of master secret, nonces and the constant. And the function that is applied in both the cases is a HMAC style function. It could be a SHA or MD5. Now there are 6 derived secrets. Let's see what are these 6 derived secrets. The 6 derived secrets or functions are: 1 is the initialization vector, which is used for encrypting messages from the client to the server. Now initialization vector for encrypting messages from the client to the server, and similarly another initialization vector for encrypting the messages from the server which is sent to the client. Now the third derived secret is the secret key for encrypting messages from the client to the server. Now there is a difference between initialization vector and the secret key. Now the initialization vector is used in the initial step of the encryption process, whereas the secret key is used in every step of the encryption process. The secret key for encrypting messages from the client to the server is the third derived secret. Now the fourth derived secret is the secret key that is generated or derived for encrypting the messages from the server to the client. Now there are 4 derived secrets which are used in order to encrypt the messages between the client and the server to the client. Now 2 of them are initialization vectors and 2 of them are secret keys. Now what is the 5th derived secret? It is a secret which is used for computing hash on the messages from the client to the server. That is the client MAC secret. And the 6th one is secret for computing keyed hash on the messages from the server back to the client, which we call as server MAC secret. So basically there are 6 secrets that are derived from the master secret, nonces and the constant. And out of 6, 3 are used by the client to the server, and the other 3 are used by the server to apply over the client. Now the other way of looking at these 6 derived functions are 2 initialization vectors are there and 2 secret keys and 2 secret keys for computing hash. 2 are used for encryption and 2 for computing the hash. Now let's look at what happens in step 4. After having understood what happens in step 1, wherein the client and the server are deciding on the protocol suite, and in the second step, what's happening? The server is sending the server certificate and the client is validating or verifying the server's credentials. In the step 3, the client and the server are deriving various secrets or the keys that are required to perform encryption or hashing or initialization vector. It is responsible for computing the pre-master secret, master secret, and the derived secret. Moving further, in the step 4, we need to check. There is a check on integrity verification of handshake messages, and also there is server authentication that is performed. Now over here, this is the only step that involves maximum number of messages communicated between the client and the server. 2 messages are sent from the client to the server and 2 messages are in turn sent back from the server to the client. Now the 2 messages sent from the client to the server are changed cipherspecs message and the other one is the finished message. Similarly, the counterpart of this is 2 messages are sent from the server to the client. The first message is change cipherspecs message, which is coming from the server to the client, and the other one is the finished message, which is again coming from the server to the client. This is the last message for establishing the handshake. Now what happens in each of these messages? Let us see. Now change cipherspecs message, what does it mean? Now over here, this message signals that henceforth negotiated cipher suite and keys must be used. The keys, cipher parameters or the suite that are negotiated in the step 1 and the keys computed in the step 3 must be used for further communication. And what does the finished message signify, which is sent from the client to the server? It serves as an integrity check on the previously hashed messages. Now there are so many messages that were exchanged between step 1, step 2 and step 3. We need to check, since all of them are sent in clear, we need to perform an integrity check on these previously sent messages. A keyed hash on the concatenation of all the messages sent in the preceding steps along with the predefined constant is performed in the finished message. Now after these 2 messages are sent by the client to the server, the work of the server is again to verify the computation of the hash which is done by the client. Okay, the server first calculates its own keyed hash over previous messages and the predefined constant, and then sends this keyed hash to the client. The client receives this keyed hash and then verifies this keyed hash. If the keyed hash gets verified, in that case we say that the server is authentic. Now the authentication of the client in case of SSL is optional. SSL handshake is optional. Now let's get back to this diagram. Now let's have a summary of what's happening in this SSL handshake. Now in the step 1, we are aware that 2 messages are exchanged between the client and the server. The client sends a client hello message and the server sends a server hello message. Now both of these messages are used to decide upon the cipher suite that will be used for this particular session. The next step, what happens in step 2 is the server sends to the client the server certificate. the server receives this certificate, the client receives this certificate from the server and verifies the credentials of the server. Now once this verification is performed, though the credentials of the server are verified in this particular step, still the client is not confirmed that the server is authentic. Now this authentication of the server is proved only in step 4. Now the third step, in the third step what happens is the client sends a client key exchange message to the server. Now this is the only message that is exchanged in the step number 3. Over here in this particular step, the client and the server establish various keys that are required for further communication in the session. Now the keys that are computed or communicated are the pre-master secret, the master secret, and also the derived secrets. 6 derived secrets are used in this particular step, or are derived in this particular step. Now these 6 derived functions or derived secrets, out of these 2 derived secrets are called as initialization vector, that are used for encrypting messages from the client to the server and vice versa. And next 2 derived secrets or derived functions get us with the secret key, which is used for encrypting messages from the client to the server and back from the server to the client. And the last set of 2 derived secrets include secrets for computing keyed hash on the messages, which are sent from the client to the server, which we call as the client MAC secret, and also from server to the client, which is called as server MAC secret. So having understood these basic secrets, we move on to step 4. Now in the step 4, there are actually 4 communications that are involved. The first 2 communications, that is the change cipher spec and the finished, these 2 communications are sent from the client to the server. And then further, there are another 2 communications which are sent by the server to the client. Now what happens in the first 2 messages that is sent in step 4 by the client to the server is, the client instructs the server that henceforth the communication between the client and the server will be using the protocols, the cipher suites which was negotiated during the step 1 with the client hello and the server hello message. The second message in this particular 4th step refers to finished message. This message will include a keyed hash on the concatenation of all the messages that are exchanged previously, along with a predefined constant. Now this keyed hash will help in checking the integrity of the messages that were previously exchanged between the client. Now once the server receives these 2 messages from the client, the server again verifies the information received from the client by computation of keyed hash. Now in order to compute the keyed hash, the server uses the previous communication messages. Along with that, it uses predefined constants and then sends this computed key hash to the client. The client verifies the keyed hash, and at this point it is able to verify that this message has actually come from an authentic server. The authenticity of the server is established only after this particular steps, or only after the step 4. Now the question that arises over here is, the client is not authenticated to the server. The authentication of the client to the server in SSL handshake is optional. If the server wishes to authenticate the client, it can authenticate by sending more messages. Now here we come to the end of session 11, in which we have discussed about the security at transport layer. Now in this entire session we have discussed about the SSL protocol, how it makes the application layer protocol secure, and what are the various protocols involved in the secure socket layer protocol stack. One is the handshake protocol and the other one is the record layer protocol. And also we have discussed the 4 steps that are involved in the SSL handshake. Now in the next session we will be discussing about the key design ideas, and also we will be discussing about OpenSSL and add a bit of server authentication, and along with that we'll also discuss secure socket layer record layer protocol in detail. Have a good day. Thank you. If you have any queries, you can revert back on this particular email or this particular phone number.